Hello, everyone. Thank you for joining us today. We have a very special guest. This is Dr. Ben Hamlington joining us from NASA. Thank you for being here. He's actually a research scientist in the Sea Level and Ice Group in the Earth Sciences section, doctor in Aerospace Engineering Sciences. Thank you very much for joining us. It's a pleasure to have you. Hopefully, we're going to learn a lot today.
Thanks for having me.
Okay, so we're going to be discussing today a specific program. We're talking about SWOT, space, water, and ocean topography. What is it that you can tell us about it?
Yeah, so SWOT is this really cool new mission. So it's called the Surface Water and Ocean Topography Mission, and it measures almost all surface water here on Earth. So when I say almost all surface water, that means the water that's on land, but also the water that's in the ocean. And that's a really big thing. This is the first time that we've ever been able to do that from space and actually measure the height of that water. So it's not just how much water there is or where that water is found, but actually the height of it and how it changes through time.
So we know that this is a collaborative project. Can you please tell us what are the different countries working within the program currently?
Yeah, so at the foundation of the SWOT mission is this international collaboration. So NASA is working alongside partners at CNES in Europe. So a France-based space agency. And we also have partners at the United Kingdom and Canada. So these different countries have come together to develop the mission and then launch the mission. And now that it's up there in space, kind of understand the data, collect the data, and make that data public. So that international collaboration is a really key part of what we're trying to do.
Is there any Colombian scientific participation? Just curious.
Yeah, so there isn't right now, but I think there's a huge opportunity as that data becomes available. It'll be available to everyone in the world, scientists in Colombia, scientists in every country. So I'm really excited about the potential to use the data and ultimately for that data to be useful for scientists and planners and other people in Colombia.
Okay, now that you're mentioning actually the availability of that data, the countries that are currently working within the project, are they going to be able to access that data equally or?
Yep. So at the foundation, kind of a guiding principle of what we do here at NASA is open science and open data. So the data that we have here in the United States is going to be the same as what's available to those in Colombia or other countries. So everyone will have equal access to the data. We're still in this phase of kind of calibrating and understanding the instrument and producing the data products. So the data is not publicly available yet, but will be very soon. And like I said, it'll be available to everyone across the world at the same time.
I know it's, you were just mentioning before something about the calibrating era and how you're in that phase, but could you please explain us currently what's happening with the satellite in what phase are?
Yeah, so the SWOT mission is kind of a new technology. It's a step forward in terms of how we're measuring the ocean and water on Earth. So it does take some time to understand exactly what the measurement is like, what it's telling us about Earth. And we do this calibration and validation phase, which is really just checking out the data and checking out the instrument. So for the first about 6 months of the project, the satellite launched in December of 2022. The first 6 months were in this calibration and validation phase. In July, we shifted to this new phase, this what we call the science mission or the science orbit, where we're starting to get that data that we expect to meet the science goals and objectives of SWOT. So we're now in this phase where SWOT is sampling the Earth every 21 days. We're getting that data down, we're collecting it, and starting to produce data products that will be released to the world.
I know it's pretty early in the project, but is there anything that you can tell us about the findings that you already have collected?
Yeah. So just a top level finding. It's super exciting what we're seeing so far from SWOT. The data looks tremendous, even exceeding our expectations before the launch actually happened. So we're seeing these really small scale features. When I say small scale, we're just seeing these features in the ocean. We call them eddies. These kind of like ocean weather. It's things that happen on relatively short time scales and are small, down to 10 kilometers or less. So with SWOT, we're able to see those features in the ocean in a way we've never been able to see before. Over land, we're seeing rivers that are of widths less than 100 meters. So almost every river on Earth, we're able to see and measure the height change over time. So it's just this new view of the Earth that we've never had before. It's almost like we've had had problems with our vision. We couldn't see very clearly. Then all of a sudden we put on these glasses up in space and able to see this great detail that we've never been able to see before. So it's just looks very exciting. I'm really excited for people to get their hands on the data.
Well, honestly, it sounds amazing that we get to see such detail from space. Now, could you please explain us a little bit about the hydrological cycle and what is it that we're learning with the SWOT?
Yeah, so the hydrological cycle is really this connection between land, ocean, and atmosphere. So we have this movement of water that happens and these deep connections between ocean, land, and atmosphere. And that really impacts the water availability here on Earth. So being able to see the hydrological cycle and the connection between those different bodies, the land, ocean, and atmosphere, is something really powerful with SWOT. So as I mentioned, SWOT's not just measuring the water in the ocean, it's also measuring the water on land. And we can see the transition, the trade-off between those two reservoirs, land and ocean. And it's really going to tell us a lot about the global hydrological cycle. We know climate change is becoming a serious issue in a lot of different areas. There are expectations that climate change is going to affect water availability and the water cycle. So with SWOT, we really hope to gain valuable insight into what's happening and how the water cycle is changing over time.
Of course, you were mentioning you're still in the early stages, so it's way too soon to say something about, I don't know, what countries might be the richest and the poorest when it comes to water resources, or is there any way that we can already tell?
So with the SWOT data, we're still in this early phase, as I mentioned, but I do think that that's really a power of SWOT, is that we will be able to track water resources over time. So I mentioned we're able to see rivers in new detail. We're also able to see lakes and reservoirs and how they're changing over time. So we can tell the height of a reservoir and how that height is changing. So we're not just seeing the reservoir from space, we're actually measuring the height of it. So we can look at volume changes over time and really provide very useful information to water resource managers in Colombia, to farmers, people that rely on water for their livelihood and for their countries. SWOT's going to be able to provide information for them. So while I can't say exactly who has the water and who doesn't, and how that's changing right now, I do think SWOT will be an important role in kind of monitoring that as we go forward.
I'm very curious about, this is such amazing technology. Could you please tell us, like, how long has it taken the development? Because you just launched it last year and you were mentioning everything, but this looks like it's been a project of a lifetime. So
yeah, that's a really good question. The start of SWOT actually goes back over 2 decades. So the idea for this type of measurement and what we could do with it originated with a group of scientists. Again, 2 decades ago. I was in a very early stage of my career and no place to be working on something like SWOT at that time. So to see that transition and that development over time and all the work that's gone into it, I think it's really made this moment even more rewarding to see the fruits of that labor, to see the success that it's become, really largely based on that long time frame development and the commitment from NASA and CNES and some of the partners that are working on this project. So it does take a long time to develop these new technologies and to launch them, and SWOT's another in that kind of vein.
Yeah, I'm sure it must be really, I don't even know how to, like, fascinating to be part of such a thing. This is...
Yeah, and I came in relatively late just in the past few years. I've been working with SWOT and trying to make some additional connections with it. But just so much appreciation for the hard work that people who have been with the project for those full 2 decades have put into it.
I'm absolutely fascinated with it.
Yeah.
And so what can you tell us about the relationship? You briefly mentioned the climate change before. It is a reality indeed. And what can you tell us about the relationship between freshwater and ocean resources and climate change?
Yeah, I mean, so SWOT is going to tell us a lot about the Earth, and there is a part of SWOT that really makes it a climate change mission. So we're going to learn a lot about climate change in a number of different ways. So I mentioned those small scale features in the ocean, that kind of overturning, that mixing of the ocean. SWOT's going to tell us a lot about that. And the reason that's so important is right now the ocean is absorbing so much of the heat trapped by our atmosphere. About 90% of the heat trapped by our atmosphere goes into the ocean. So in some sense, the ocean is really protecting the Earth right now because that heat is getting trapped in the ocean. That means it's not heating up over land and causing places like Colombia to get even hotter. But if that changes over time, if the ocean becomes less able to absorb that heat, then again, that impacts what's going to happen across the Earth. So it's going to inform us about the important role of the ocean in climate change. It's going to provide measurements along coastlines of the Earth in a way that we haven't been able to before. So it's going to tell us about sea level rise and coastal flooding, allow us to better predict the sea level rise and flooding that we'll see along coastlines across the globe. And then the last one is really the presence of droughts and flooding. So we know that because of climate change, some places are going to have more water, and some places are going to have less. And SWOT's going to really tell us about how the global water cycle is changing and give us some indication of what we might expect in the future.
I was actually going to ask you about that. Natural disasters are just, I mean, it's hard to predict. And it sounds like maybe SWOT is going to be able to help us predict all of that. So it's safe to say that probably it will.
Yeah, exactly. So SWOT data, I think, will be able to be put into models that we use now and just really improve those models that we use to predict coastal flooding, drought and flooding over land. So it's really filling a gap. I mean, we just didn't have data in these areas. We didn't have data across all coastlines of the world. We didn't see all the lakes and reservoirs. So SWOT's really going to fill that gap and allow us to improve the models that we rely on right now.
There's another thing that I wanted to ask you. A recent study revealed that 56% of the global sea surface has changed in the past 2 decades, actually. So that meaning that the ocean color changed to more green. So SWOT is going to help us understand what's behind that change and how bad is it and how that's going to affect life on the planet.
Yeah, so SWOT won't see the color change itself, but that color change is associated with a lot of other processes that SWOT will help us see. So again, that kind of mixing of the ocean and those small scale features I talked about that SWOT will measure, they do play a role with some of these color changes and some of the biological activity that's happening in the ocean. So SWOT's really going to complement other measurements we have from satellites like that were used in that study. And then allow us to answer some of these questions and get additional detail.
And you're quite excited about the project, I can tell. Can you please tell us what is it that you're currently expecting to get from SWOT? What are we waiting for?
Yeah, I mean, I think that the data is going to hopefully be released, let's say by the end of this year or early next year to the public. And I think some of the nearest term things that we're going to see value from SWOT. So in terms of the science, the ability to see the connection between the land and the ocean and what's happening along our coastlines, I think that's really going to be a step forward in terms of our scientific understanding of what's happening along the coastlines and how sea level rise is being affected by climate change. In terms of more like an application or use of the data, I think that we're very quickly going to see uses for water resource management. So immediately we'll be able to provide a monitoring system for the reservoirs in places like Colombia's and the lakes that are relied on for fresh water. So I think that's a really key piece that we'll see from SWOT. And I think beyond that, it's such a new type of observation. It's hard to predict the ways that it'll be useful. I think scientists and people around the globe will get access to the data and explore it in new ways that I can't even predict. And I'm excited to see that part of it as well.
I would think that's probably the greatest part, the fact that everyone is going to be able to put their hands on and just keep contributing, keep working on it. This is finally the work, like I'm amazed to the fact that we can get so much info from space. You wouldn't think that would be the way to be
Right,
honest.
yeah. Yeah, I mean, the engineering on SWOT is very impressive. That's not my work. I'm more on the science side, but the work the engineers have done to develop this technology that allows us to see all these things from space is really incredible. So yeah, I'm definitely excited to see the potential and what can come from these measurements.
It is unbelievable that we actually know more from the space and from our own ocean. So it's great and kind of ironic that we now get to learn more about the ocean from space.
Yeah, and I think that another key part here is that the observations we make from space really complement what's being done locally. So I know in Colombia, there are measurements that are being made along the coastlines, and there are measurements of the lakes and rivers, and the observations we have from SWOT don't replace those, but they really just add value. So they give you that much of a better look at what's going on, and kind of complement the hard work that people are doing across the globe, looking at more specific areas. So these two things really intersect in a nice way. And I wish I could share more of the data. I mean, we just don't have it. We're not in a phase to make it public yet, but yeah, some of the stuff is just looks amazing, and what we're seeing. So soon enough, though, it's only a couple months away, then we'll be able to put everything out in the public.
I'm curious about another thing, a little bit more personal. But did you ever think that you would be working in such a thing from NASA also?
Yeah, I mean, it's been a weird pathway to get to where I am today. So I did start as an aerospace engineer working in kind of a different part, but then have just shifted over time to work more on the ocean. My background and expertise is actually very much in like sea level rise and coastal flooding. I lead a team called the NASA Sea Level Change Team, which is like a broad group of scientists that we try to provide projections of sea level rise and coastal flooding across the globe, including Colombia. But there's this intersection between all these missions we do at NASA, including SWOT, with that work. And yeah, it is amazing to think about the ability within NASA to generate an idea, like here is what needs to be measured, develop a technology, and then to launch that into space. Like to see that through to the point where there's a satellite in space is just really cool.
And people who worked at the beginning of the project and who developed the idea and starting to see the results 20 years later, it's just like,
it is interesting to think about, because like we're talking about new satellite missions now, and so like the people who started working on SWOT are like close to retirement now. And then I'm at that phase where I'm like talking about additional satellite missions. And then am I going to be at that same point 20 years from now where something we're talking about now is being launched? I'm about to retire. I don't know. It's just hard to it's interesting to kind of map your own career onto those that have come before you.